So, just want to thank Abel and the CBC for hosting us. I think this is maybe our fourth year of presenting as BuildX, but I'm Ryan Howsam, CEO and founder of BuildX, along with my friend and co-founder Leo, who I've known for 25 years. We're based out of Denver, Colorado, and BuildX exists to reduce preventable claims um, to zero. And so I've spent 25 years in the construction industry, running a construction risk management practice for one of the largest management consulting firms focused on construction, FMI. And Leonard's going to walk through where we are today with BuildX.
Yeah, thanks, Ryan. And it's great to see everything evolve, Abel, uh, and great segues from the last conversations here, because we really did start, uh, what, 3 years ago now, talking about uh, tokenizing data with digital wallets and putting O&M manuals for some GCs here in Colorado on chain and making all that information verifiable. And now we've made a bit of a move more towards AI. And we'll go through that change and why in this presentation. So early on, Ryan identified that, even though most GCs and people in construction aren't going to know much about data sovereignty or think much about it, uh, what we continually get asked is what happens to the data and who owns the data. I think uh, most people in the industry are a little bit shell-shocked and concerned about vendor lock-in, those kind of typical concerns that there's tons of information and unstructured data that gets lost, so it becomes inactionable. So even though people don't talk necessarily about data sovereignty, that is, we believe, what they're asking for. Our kind of North Star is what we call veiled, because we're here in Colorado, is verifiable, which we just talked about. Digital signatures, having things verifiable on chain if needed, accessible, intelligent, and lasting. Because this information oftentimes might be needed for as long as the building is operational and maybe even after the building is complete and torn down again. So we started back in 2023 with on-chain data where our CTO had built a naming system on ENS. So we had taken ENS name hashing and built a data structure so that you could look at, say, a building and an address and then see a lookup through the name hashing where that information was. You'd always have a lookup to the information based on the keys of the user and the address, and sometimes a combination with the keys of the owner. So we abstracted a lot of that into the background, and we've taken a lot of the learnings from that to build more identity-driven knowledge graphs, which we'll talk about. This is based on HT wallets for those that are familiar, hierarchical deterministic wallets. Essentially, it makes a data structure out of these wallets so that each individual data point has a crypto address associated with it. So it always has a way to look it up and a way to validate it. And there's a lot of benefits to that. You may have heard of security by design. Basically, that means that because each data element has a key pair associated with it, if there's a breach, generally the breach is going to be limited to the combination of keys that hold the data. There's a lot of crypto tooling that goes into that in terms of how the tree of commits, each database update essentially is a commit similar to a transaction that goes on chain, but those can all be put into, multiple data updates can be put into a single transaction on chain. And then we have some unique trees that allow for really ultra fast lookups, so you can get more kind of enterprise grade responsiveness even with this crypto infrastructure. But we did figure out early on that what really matters is that this data is useful. Just having the data verifiable isn't enough. It also has to be intelligent. And we've seen, with the massive valuations and those follow massive ROIs, I think, with and we've seen it in construction already, because it's so based on things like PDFs and tons of unstructured data. AI is making really great inroads into pulling out information that's valuable. But going back to our original point, it does need to be verifiable and lasting. So this is where we're at today. We've built out, based on some of that decentralized storage that we're going to be pulling back in 2026. We now have a fully featured AI orchestration and agent orchestration layer, along with a typical kind of Slack-like interface, so that we can have team members interacting with AI agents that become specialized. A big part of that is our AI message queue, and we're going to be open sourcing that as soon as it gets fully tested. It's actually in production right now, and we're testing it with users. We hope to open source that in early 2026. That's combined with the knowledge graph that we'll go into in a little bit, the decentralized backend, and then the agents are interacting with people in kind of a Slack channel. And we can specialize the agents for things like bid leveling, risk identification, and sentiment analysis. We'll show a little bit about the sentiment analysis, but this messaging queue allows us to really quickly provide AI services and build these specialized team members. And the kind of cool thing about it, as we move to this age of AI, is we don't really need much of an interface. We're working today allowing these AI agents to interact via email. We're going to allow them to interact via Telegram channels. So once we get these agents set up and people can architect them in a sense on their own, they can start interacting and pulling information from all the various sources that they need to, like Ignite. And we do that in a way where, using knowledge graphs, we take this unstructured data. This is a quick example of John Doe, the project manager, needs to resolve a water leak on level 3. That unstructured data is pulled into a knowledge graph seen below, where it works very similar to the way our minds work. We relate concepts and things over time. And through a structure like this, and this has become a common architecture in AI now, LLMs working like this. So the LLM and the natural language processing pulls the information and the relationships out through these triples, subject, predicate, and object. And the triples get held in the knowledge graph, but then become more refined over time. So in a sense, they learn, and those relationships between the subject, object, and predicate become more refined and clearer over time as the system learns and repeats and gets feedback. This is just a further on that, essentially taking unstructured data, creating the triples, and then allowing the queries to happen. The message queue is a big core component of the areas that we've built, and allows us to have these distributed AI tools that we can pull in really, really quickly. I mean, we can pull in different kinds of tools in essentially overnight. We've done that with sentiment analysis, which I'll show here in a second. This is a real example from a big project showing that it's read through. You can read through emails, you can read through PDFs, and look at this was a big request made by one of the presidents. I don't know if you can speak to this, Ryan.
Sure. Yeah, one of the lessons we found through multiple pilots and onboarding over 500 buildings currently onto our platform um, was project documentation uh, is great. When you're handing off that documentation, say in an O&M manual when the project's complete, is helpful. But if BuildX exists to drive these preventable claims and disputes, of which 30% of projects have disputes or claims, and we're trying to drive that to zero, what we discovered working with the large GC on a $4 billion project that we have BuildX on out of Las Vegas is the communications is the earlier driver of cause and effect of dispute and claims, where you can start to pick up issues that happen. So in this case, the sentiment analysis is looking at communications, which can be emails, text, Slack, or even recording actual meetings or project walkthroughs with superintendents and subs. And in this case, the BuildX system picked up, hey, they've lost nearly a week of productivity. And architects not responding to an RFI. The drywall's already started to stack in the hallways. And this is a precursor to potential disputes and claims because of lost time or stacking of trades. So we've really focused not only on the project documentation, which you can tie through to the individuals, but also on the earliest communications that we can start to capture in those knowledge graphs.
Great, thanks. And so this is where we're heading in 2026. So a lot of people have talked about security and privacy within the AI space. The place that everybody wants to go is towards a really private map, so that when you work with an LLM or you work with another AI tool, that information that you're seeing is private. So our goal in 2026 is to take a lot of what we've learned about how we can create data structures that are private using some of these crypto tools and build that into the knowledge graph, so that essentially you can have one large knowledge graph for the company, but you only see those subjects and objects and predicates based on who you are and your role and the time that you're working on. I remember Abel talking to us a couple of years ago, I think now, about one of the big issues is trying to find out who is the right person to work on something at the right time based on their role. And this is the kind of thing that we can get to, so that you can know, which contractor worked on a specific project and who to contact immediately when an issue needs to get resolved. And so we've built prototypes on this already without the crypto backend. So that's all working and in production right now. And in 2026, we'll be working on implementing some of the crypto backend that we've developed previously and putting this all together. So this is an example. Somebody worked on a surgical suite heating issue, and you want to know who can fix it at this moment. Find out who the contractor is that has the clearance and knows the system and is currently available. That's really the vision that we're getting towards. So pulling this all together, finding the right person at the right time, being able to verify credentials. As Ryan has brought up, the liability protection by being able to see problems through things like sentiment analysis, but also different agents that work on things like risk identification. And because there is this feedback loop into the knowledge graph to strengthen or weaken relationships over time. We get better and better results with time. So right now we're in a 10 building. We're pilot with sentiment analysis, the team channels. And again, we have agents that can work through email, that can work through Telegram, and work in real time. The real time aspects of this are sometimes difficult, but we've been able to overcome some major things working in real time with team members. So it really is becoming more and more like you have AI team members that have specific skills in your channels. And of course, this is all verified. We have it so that you can look up the source of the information when an agent identifies either a risk or makes a statement. You can always ask the agent where the information came from, and it'll be able to point back to the specific email or the Ignite folder or wherever that information came from. I'll let you wrap up, Ryan.
Yeah, so really excited from where we've started and how AI is playing a central core to what we're doing, and then with our AIMQ open source software, it's really quite an amazing queuing system that we're really excited to share with the industry and have multiple people be able to utilize that tool and others to build on our platform. So, again, thanks to Abel and the CBC for your time. Looking forward to collaborating with everybody.